Hi everyone, today's topic will be moles of molecules to mass and mass to moles. My name is Rahul Kumarison and I'm an AP chemistry student in Robinsonville High School. Our learning objective is that by the end of this video, you'll be able to convert from moles of molecules to mass and from mass to moles. So, why are these concepts important? Particles cannot be counted or measured directly. A chemist is rather interested in the macroscopic world, which includes kilograms and grams, rather than the microscopic world, which would be atoms and molecules. We want to be able to measure chemicals in grams rather than individual atoms and molecules. So we use moles to connect mass and the number of particles undergoing a chemical reaction. So a little bit of review. These are four terms that you should be familiar with by now. So mass is the amount of matter in an object. It is measured in grams. Moles is the amount of a substance that contains the same number of particles as atoms in 12 grams of carbon-12. Molar mass is the mass of 1 mole of a substance. It is measured in grams per mole. And dimensional analysis is a method for setting up mathematical problems. Mathematical operations are conducted with units, which are cancelled until only the unit of the desired answer is left. And we're going to be using a lot of that today. So molar mass. It is mass of 1 mole of a substance. It is derived or calculated from the periodic table. So the molar mass of helium can be read directly off the periodic table. It is going to be 4.003 grams per mole. The molar mass of carbon is going to be 12.011 grams per mole, just read out directly off the periodic table. And the molar mass of water has to be calculated. So it's going to be 2 times the molar mass of hydrogen, so 1.008, plus the molar mass of oxygen, and that's going to be 18.015. So we're going to be looking at Avogadro's number next. Avogadro's number is the number of particles, so atoms or molecules or ions per mole. Its value is 6.022 times 10 to the 23rd. Avogadro's number relates the number of particles to the number of moles. So here's a little diagram that I would like to show to you guys. So there's going to be 1 mole of all of these substances, and each has a different molar mass. But all of them have the same number of molecules or atoms per mole. So 6.022 times 10 to the 23rd particles is 1 mole, and that is also equal to the atomic mass in grams, so the molar mass. So how do you get the number of moles of particles? So say you're given 1.2044 times 10 to the 24th CO molecules, and you want to know how many moles of CO molecules is that. So you're going to put the given here, and then you're going to use your conversion factor. So 1 mole is equal to 6.022 times 10 to the 23rd molecules. And then units cancel, and then you're going to get 2 moles CO. So if you don't have a calculator, I suggest that you change 1.2044 times 10 to the 24th to 12.044 times 10 to the 23rd. This concept was covered in the scientific notation video. So then you can see that this times 2 would equal this. So then you get 2, and if you are using a calculator, don't forget your parentheses. So next we're going to be looking at moles of molecules to mass. So we're going to be using molar mass and dimensional analysis. So if the question asks, find the mass of 4 moles of carbon dioxide, we're going to first find the molar mass of carbon dioxide. We're going to get 44.01 grams per mole. And then we're going to be using dimensional analysis. So the given is going to be here, and so 1 mole is going to be equal to the molar mass of carbon dioxide. Units cancel, and you're going to be left with 176 grams of carbon dioxide. Quick note, so if you're given a question like this, I suggest breaking it up into whole numbers and then decimals. So first I did 4 times 44, so 176. And then I took the 0.01 from here and multiplied it by 4, and I separated that into 1 times 4 times 0.01. Multiplied these two, so I got 4 times 0.01, and this is 0.04. And then I'm just going to add both of them and get this. Because of sig figs, it equals 176. The next is we're going to be converting from mass to moles. So we're going to be using molar mass and dimensional analysis for this too. So find the number of moles of 36.04 grams of water. So first we're going to be finding the molar mass of water, which was covered in a previous slide, and then we're going to be using dimensional analysis. So the givens here, 1 mole of water is equal to 18.02 grams of water, and then units cancel, and we are left with 2 moles of water. And next is the guided practice. So a chemist has 80.25 grams of methane. How many moles of methane does he have? So first we find the molar mass, and we get 16.05 grams per mole. So then we set up the given, and then 1 mole is equal to 16.05 grams. So units cancel, and we are left with 5 moles of methane. Next question. A chemist has 5.0 moles of ammonia molecules. How many grams is this? So first we're going to be finding the molar mass, and we get that to be 17.04 grams per mole. And then we put the given on the left, and then 1 mole is equal to 17.04 grams. Units cancel, and we're left with 85 grams of ammonia molecule. 85 grams of ammonia. Next question. A chemist has 4 moles of CO molecules. How many grams is this? So once again, first we find the molar mass, and we get that to be 28.01 grams per mole. We do 4.0 moles of CO, and we say that 1 mole is equal to 28.01 grams. Units cancel, and then we multiply and we get 112 grams of CO. So let's do a little bit of practice. So stop the video and answer the following question on your own. A chemist has 90.25 grams of ammonium. How many moles of ammonium does he have? Okay, so first we find the molar mass of ammonium. So that's just going to be the molar mass of nitrogen, 14.01 times plus 4 times the molar mass of hydrogen, so 1.01. We get that to be 18.05 grams per mole. And then we set up the given on the left, and then so 1 mole is equal to 18.05 grams. Units cancel, and we are left with 5 moles of ammonium. Hope you got that right. Next question, please stop the video and answer the following question. A chemist has 3 moles of hydrogen peroxide. How many grams is this? So first we calculate the molar mass. So 2 times the molar mass of hydrogen plus 2 times the molar mass of oxygen gives you 34.02. Put the given on the left, and we say 1 mole is equal to 34.02 grams. Units cancel, and we're left with 103 grams of hydrogen peroxide. So lesson takeaways. Particles cannot be counted or measured directly, so we use moles and mass. So to convert from molecules to moles, we use Avogadro's number. And to convert from moles of molecules to mass, we use molar mass and dimensional analysis. And to convert from mass to moles, we use molar mass and dimensional analysis as well. And that's it for today. Thank you so much for coming.